Alrighty, geometry students, welcome to homework 3.4 on perpendicular lines. This is uh, the uh, the notes for that section. So we got a couple definitions for you and some questions. So we're still working on transversals. We're now in the second half of this chapter, and this chapter will deal with some of the angle relationships we talked about, but in terms of what if those lines are perpendicular. So let's look at the first definition, which is just perpendicular lines. Let's a basic one, but we want to remind ourselves they're lines that intersect at a 90-degree angle. So basically a T. So we've got basic example of 90-degree lines. All the lines on this graph paper are all perpendicular lines. So you know when you have perpendicular lines that is in fact 90 degrees. They'll usually use the little red box. The other thing just to point out is that if I have an intersection like this and I have a 90-degree angle, that tells you all the other three angles as well, because this one over here has to also be 90 because these two together are 180. So you know that that one's 90, and then you also know that, of course, that all of these others would be 90. So in addition to the fact that they always equal one 90-degree angle, just that, of course, means that all four angles are 90 degrees, totaling 360. Okay. The other thing, too, that I wanted to point out is that when you have perpendicular lines, that what you've created, actually, let me draw it this way. You can create a linear pair where these two angles, you have this angle and this angle, they are both congruent and supplementary. So in other words, whenever something is congruent and supplementary, in other words, they add up to 180, but they're the same, you know you have 90-degree angles there, and therefore you have perpendicular lines. So just sometimes that's how it's phrased. That's one of the implications of perpendicular lines, that what you've created are two angles that are congruent to each other, they're always the same, and they're always supplementary. They add up to 180. Okay, so perpendicular lines. Let's see, what else do we need to look at? Let's apply it to transversals. Perpendicular transversal theorem. If a transversal is perpendicular to one of two parallel lines, then, we got a conditional here, then it is perpendicular to both lines. Okay, so what are we talking about here? We're talking about we have two lines, okay, and then we have a transversal cutting through those two lines. All right, this is what we've been working on all week. And it's saying here, I'm going to name these two lines A and B. And it says if it is perpendicular to one of those lines and the two lines are parallel, so I know that A and B are parallel, do I know that this intersection here, do I know that that is for sure 90 degrees? Based on what we've talked about, we do, because think about what we've talked about. We said that if two parallel lines are hit with a transversal, then I would know that this angle here, which is the corresponding angle to the one above it, this and this are corresponding angles, then those have to be the same. So if I know that the top one is a right angle, then I know that this one has to be the same amount, also a right angle. So again, I know super exciting stuff, but that's what the transversal theorem says, is that if you know one of the angles is 90 degrees, then you can infer that the other one must also be 90 degrees. Okay? Alrighty, let's take a look at the questions. Okay, question number 1 asks, what is the shortest point between a line, or the shortest distance between a line and a point? So we've got a line here and there's a point, and you could connect these with all sorts of, you know, rays, all different points. But how do you always know which is going to be the shortest distance? If you look at these, it's always going to be this one right here, the perpendicular line. That if let me just draw another example of this. Take any line and then put a point out there. The shortest distance between that point and the line is always going to be a line that goes perpendicular to the line. Okay, so we should put that into writing. We'll say the line well, let's say it this way. A perpendicular line. Not going to have any space for that. A perpendicular line will be the shortest distance. Okay. All right, and you'll see in question number 2 how that then applies. Okay, so question number 2 is out of our text, I think, right? Oh, let me make sure I actually get to the proper questions here. All right, question number 1, what is the shortest distance? Okay. Number 2, what do you know about angles if they are a linear pair that is congruent? Okay, so this is what I just did. There we go. All right, so if we have a linear pair where two angles are congruent, this is what I was saying when I was defining perpendicular lines. If I know that this line or angle is congruent to that angle, and they're forming a linear pair, well, not only do I know that they're congruent, I know that they must be congruent right angles, because there's no way to take the 180 degrees, divide it between two different angles that have to be the same, and get anything other than 90 degrees. So I know that the two angles, to answer the question, I know that the two angles are 90 degrees. I also then know that the lines, if the angles are 90 degrees, then the lines are, I'll use the symbol, perpendicular. Okay, so if you have two angles that form a linear pair and their angles are congruent, then you know that you have right angles, 90-degree angles, and you know that therefore the two lines are perpendicular. Okay, question number 3. This one is the converse of the perpendicular transversal theorem, in that it says, what if you know that a transversal is perpendicular to two lines? Well, if I know that these two, it's perpendicular in both these cases, what I can then learn, or infer, conclude, all those synonym practice, is that the lines are parallel. You can conclude that the lines are parallel. And I'll use the symbol for parallel, double L. That's not an 11, that means parallel. Maybe that looks a little confusing, I'll write it out. Okay, and notice this is just the converse of the theorem that we did up here. Perpendicular transversal theorem said if a transversal is perpendicular to one of the lines that are both parallel, then I can infer that this other angle must also be perpendicular. This question is basically saying, what if you know first that they're both perpendicular? Well, then you can conclude that the lines are parallel. So again, you're taking the two ideas. You're taking the idea of them being parallel and concluding they're both perpendicular, or you can reverse that and say, if they're both perpendicular, then I can conclude that the lines are parallel. And that would be the converse. Just like we learned all the converses of these special angle relationships. If you're using the angles to prove the lines parallel, that's the converse, okay? And I could even write that out, but we'll just talk about that in class. Okay, so then question number 4, these are the ones that come from the text. So let's look at page, number 2 in our textbook. Number 2 says, name the shortest segment. This is the drawing that they have. It said, name the shortest segment from point E to line AD. So in other words, from this point up here, what is the shortest distance to the line right down here? Well, and you can see that one of those lines is perpendicular. So this goes back to the first question of the section. This line right here is going to be the shortest distance. So we can say that that is line EB. Okay, so line EB is the shortest. Whichever line is perpendicular will be the shortest. And then it does this thing that I wanted to just show you what they mean. It's fairly simple, but you might be confused at first. It says write and solve an inequality for x. So they give us two measurements. We know that EB is 7, and we know that ED is x plus 12. And so rather than write an equation, we can write an equality, because I don't know what those things don't, EB and ED don't equal each other, but I do know that one of them is definitely shorter than the other one, right? Because that's what we just said in 2. We just said that EB is the shortest distance. So that means no matter what ED is, EB has got to be smaller than it. So my equality would look something like this. Well, first, let me just write out. The idea is, so EB has to be less than, that's an inequality, ED. Okay, because EB is perpendicular. Then I could just substitute. 7, therefore, is less than x plus 12, whatever x happens to be. And then if you just remember, you can solve inequalities just like you would an equation. If I want to get x by itself, I can just subtract this 12, which cancels out. And so then I get x has to be greater than negative 5. And so an inequality is just like an equation, but it doesn't say they're equal. It says one is for sure bigger. So I know x must be greater than negative 5. And again, how did I set that up? Well, because you just set up the perpendicular line, which is EB, or 7 in this case, has to be smaller than the segment ED. And then you just make sure you put the values in there and solve for x. Okay, let's take a look at question. Last one, number 12. Number 12, we have to solve for x and y. Now, this one can look tricky because notice there's 2 variables. So 1, we're thinking, okay, I got to write an equation, but 2, how do I write an equation when I have an x and a y? Well, let's take a look at our picture. Notice that they've told us that the lines are parallel. So according to the perpendicular transversal theorem, that's a wonderful thing that you can talk about tonight with your parents. If this is perpendicular here, I know that that angle up there must also be perpendicular. So let's write that in. So in other words, I know that all of these angles are equal to 90 degrees. So why is that useful? Well, that tells me I know what 2x. 2x is this angle right here. And that one, like all the other angles, must be equal to 90 degrees. So that gives me an equation that I can solve with only one variable. I can say 90 is equal to 2x. And then I can just solve. You're going to divide by 2. Half of 90 is going to be 45. So x is equal to 45. Boom. Shama Lama. And now that I know x, I can plug it in right here, and that leaves me with only one y variable to solve. Question is, do I know what 3y minus 2x equals so that I can actually write an equation? Turns out I do, because do I know what this angle is right here? Of course, they're all 90. Their lines are parallel. This is 90, so that means this is 90. That means all of these angles are 90 degrees. Notice in this case, we learned in previous lesson that, half the angles are equal. The alternate interior, alternate exterior are congruent. The other half are supposed to be supplementary. They're supposed to add up to 180. Notice here that all are the same because notice all angles are both congruent and they are also all supplementary. So we're not really violating any of the things we've already learned about these special angles in a transversal. But all that aside, let's go and we can write our second equation to solve for y. So I know that 3y minus 2x is equal to 90 also. So I can start solve from that equation, especially since I already know that x is equal to 45. So I can go 3y minus 2 times 45 equals 90. And now we just keep working with our algebra. 3y minus 90 equals 90. Okay. Don't go random and suddenly say it's 0. No, we're going to add 90 to both sides to get y more by itself. Cancels out. So I get 3y equals 180. Get y by itself by dividing by 3. And there we get, crosses out, y must be equal to 60. So y is 60 and x is 45. And we could plug that in and check it if we want to. 2 times 45 is 90. If I plug in 60 here, I get 3 times 60 is 180. 180 minus 2 times 45 is minus 90, and that also equals 90. So I know my x and my y are correct. And again, the basic version of what we're saying here is when you see parallel lines and one of the angles is 90, all the other angles are 90. Okay? And if you, again, it takes parallel lines to prove that they're all 90, or if you see they're all 90, then you do know that the lines are parallel. Okay? Because both the initial theorem and the converse are true. Okay, look forward to talking about this and clarifying things in class tomorrow. Make sure you take the quizzes online, and we'll see you soon.